and welcome back to Ganesh Institute and in this series of linear algebra. So what is here for today? We are going to discuss about inverse of a matrix, but not in a traditional way. We are using Gauss Jordan method, that is elementary row or column transformation, to see how to get the inverse of the matrix. So let's get started.
Now, if we have to find out the inverse of the matrix using Gauss Jordan method, or we can say elementary transformations, then what can we do? For instance, if we have the similar matrix which we used in our previous class, this one, and we have to find out its inverse. So, Gauss Jordan method states that you can use two forms of elementary transformations, be it A is equals to IA or A is equals to AI. When it comes to row transformation, then use IA, and for column transformation, use AI. What is I here? I is the identity matrix of the same order as of matrix. Now, let's apply. So, what we have to do, if I'm considering A is equals to IA, A is equals to IA. What is I? Identity matrix, right? 1, 1, 1 is the leading diagonal element. Rest all are 0. Here I'll place the matrix which is given to us. Now, and let it be A only, because at last we'll take this A to onto the left hand side and we'll get A inverse. Okay. Now, the purpose is we have to make this matrix as identity matrix, keeping all the rows transformations in hand. For example, to create an identity matrix from it, we need 1, 1, 1 here. So the idea is firstly create 1, then create two zeros together, then create second one and create two zeros in another step. Then first, this is 833, right? Create 1, make 8331 and two zeros all together. So let's apply. See, we have already 1 at the first place here. So let's make this as 0. What can we do? If in R2, row 2, I add R2 and R1, what will happen? Because R1 is already 1, first element is already 1, I can add these two to get 0. Okay, so this has become now, see, I am only changing R2. I'm not touching R1, neither R3. Similarly, here, R1 and R3 are same. Now, what changes we are bringing into while applying this row transformation? R2 plus R1. So, minus 1 plus 1, 0. 3 plus 2, 5. 0 minus 2, minus 2. So, 0 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. Right? Now, I need to make this as 1. What can I do to create this as 1? See, if I do, okay, if I have R2, if I can have 5 minus 4, I can create 1. Correct? Yes or no? So let's apply that one. R2 tends to R2 tends to it's not working. R2 minus 2R3. What will happen then? 1, 2 minus 2. No change in R1. No change in R1 here also. In R2, what I am doing? R2 minus 2R3. So 0 minus 2 into 0. Right? That is 0 only. 5 minus 2 to the 4. That is 1. Minus 2 minus 2 on the 2. That is minus 4. Correct? Rest. We are not changing anything in R3. In R2, what is happening? R2 minus 2R3. R2 minus 2R3. That is 1. R2 minus 2R3. That is 1. R2 minus 2R3. Sorry. Just bear with me. What is R2 here? 0. Minus 2. What is R3? 1. So minus 2. Correct? What is next? I need to make these two as zeros. Right? So what we will do here? I need to make these two as zeros. So R1 tends to R1 minus 2R2 and R3 also tends to R3 minus 2R2. Correct? Why? See, when I have this, I need to take these two same basis. R1 minus 2R2. So 2 minus 2R2. It will make 0. Then again R3 tends to R3 minus 2R2. 2 minus 0. This is what I want. So let's write R1 minus 2R2. So 1 minus 2 into 0. 1. 2 minus 2R2. 0. Minus 2 minus 2R2. That is minus 4. So minus 2 plus 8. 6. In R2, I am not changing anything. Then we have what? R3. So R3 minus 2R2. 0. R3 minus 2R2. 0. R3 minus 2R2. So 1 plus 8. That is 9. Correct? Okay. On right hand side, we have R1 minus 2R2 again. So R1 minus 2R2. This is giving us minus 1. R1 minus 2R2. That is minus 2. R1 minus 2R2. That is 4. In R2, we are not changing anything. In R3, what we are doing? R3, let me create space. So, R3 minus 2, what is R2? Corresponding R2, this 1. So, minus 2. R3 minus 2 R2, again minus 2. Minus 2, okay. Then we have R3 minus 2 R2. That is 1 plus 4, 5. Correct? Okay. Now what I'm supposed to make this as 1. How can I do it? If I have to make this 1, can I divide this R3 by 9? Or there is any other way? if I do 9 minus 6 to the 12, no, it will not work. I can do 9 plus 2R2. But if I do it, then it will change this 0. Correct? So the last option is divide by 9. What have we got? We are not changing these two, R1 and R2. So 0, 0, 9 by 9 is 1. Similarly, minus 1, minus 2, 4 as it is. 1, 1, minus 2 as it is. And minus 2 by 9, minus 2 by 9, 5 by 9. Correct? Now I need to make these two as zeros. Right? Once 1 is made, now you can easily create rest too. So if I do R1 minus 6R3, because 6 minus 6 will become 0, and then R2 tends to R2 plus 4R3. 4 plus minus 4 plus 4 will become 0, right? So let's apply. So this R1 minus 6R3, 1 minus 6 into 0, 1, 0 minus 6 into 0, 0, 6 minus 6, 0, R1 minus R2 plus 4R3. So 0 plus 4 zeros are 0. 1 plus 4 zeros are 1. Minus 4 plus 4 ones are 4. So 4 minus 4 plus 4, 0. Rest, we are not changing anything in R3. Here. Now use your operations analysis. So minus 1 R1 minus 6 R3. So 6 R3. What have we got? If you want to, 3 to the 6, 3 3s are 9. Minus 3 plus 2 to the 4. 1 by 3, right? Then what have we got? You can check the calculation on your own. Okay. We are doing R1 minus 6 R3. Okay. So R1 is minus 2 now. Plus minus 6 R3 minus 2 by 9. So 3 to the 6, 3 3s are 9. Minus 6 plus 2 to the 4. That is minus 2 by 3. Right? Initially we did minus 1, which is R1, minus 6 R3. Then we did 3 to the 6, 3 3s are 9. Minus 3 plus 4, 1 by 3. Okay. What is next? We have next one is minus, 4. 4 minus 6 R3. What is R3? 5 by 9. 3 to the 6, 3 3s are 9. 4 3s are 12 minus 10, 2 by 3. What is R2? R2 is 1 here. Plus 4R3 minus 2 by 9. So 9 ones are 9 minus 8, 1 by 9. Again, we have these two values as same. Right? This one and this one. Same as the previous one. So 1 by 9. Now next is minus 2 plus 4R3, 5 by 9. 9 2s are 18. Minus 18 plus 20, 2 by 9. Correct? And R3, we are not changing anything in R3. This is A here. So if you have this A as A inverse here, and this is identity matrix. Whenever you multiply any matrix by I, you get that matrix only. So you don't need to write it again. And inverse is this. Okay? This is how you can use Gauss Jordan method. That is elementary row transformation or column transformation. if you apply all the rules using columns, C1 tends to something, C2 tends to something, then that is called column matrix, column transformation. This is how you can find out the inverse. Okay.
If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye bye.